Okay, here is our honors pre-calculus quiz due on April 21st. We are given a problem where we have to find the force of gravity and the direction of an incline. That I put as F1. And then we must find the force of the orthogonal to that, which is F2. I drew this little diagram here just to represent what we were given. We also had some information like the force of gravity being 12, but I'll get to that later. 12 newtons, that is. Okay. So first we must find G. So G is so we know this because 12 is the newtons of force, and 270 is the direction straight downwards because gravity points straight downwards. And the x value is cosine and the y is sine. So then we put those into a calculator and we get G equal to 0, negative 12. Next, we need to find V. V is the slope. We have its direction already, and we use 1 for magnitude because we don't want to change the results. Basically, we just want the direction. So you can pretend like the 1's not even there. So that's why we use 1. So I'm going to put V right up here. We're going to use 1. Then the x value is always cosine. And we're given that it's 20 degrees. Then y is 1 sine 20 degrees once again. Simplify this in a calculator and you get V is equal to 0.940 and 0.342. Now that we have both of those, we have to find the projection with this equation. G x Vx plus Gy Vy. All of that is over V squared. And then at the end, you multiply it by the V up here. So V. And all of that is equal to our first answer, V1, or the force of gravity in the direction of the incline. So we start inputting variables into that, which we already have. That is over V squared, and V, that's the force of V. The force of V we just put as 1 again, so 1 squared, that's 1. That doesn't change the equation at all. So we're just going to have basically this top half. And then we're going to multiply that all by V. We're going to multiply it by both sides of the V. So 0.940 and 0.342. Once we put that into a calculator, we end up with negative 3.16, negative 1.08. That's our F1. But that's still not the answer, because we need to find the answer, not just in that form. We put this into our equation. F1x squared plus F1y squared is equal to F1. So that's what we're trying to find. We then put those numbers into the equation, and we end up with negative 3.34 is equal to F1. The answer actually came out as positive, but then I turned it into negative because it says the force of gravity in the direction of the incline, but it's going downwards, so it would be negative. So there's our answer for problem 1. Okay, now we're going to go to part 2. I'm just going to put part 1's answer up here. So okay. For F2, I added another variable u. That would be the direction of the orthogonal force to, because we need to put that with g to find F2, because we already have gravity. So u, once again, it's just a direction, so we use 1 Newton. Then x is cosine 290. 1 sine is y, 290. This is because it's orthogonal to the 20-degree slant. So instead of being a 0-degree slant and being orthogonal at 270, it would be 20 degrees and 290. So now we're going to find the answer to that, which would be, when calculated, u equal to 0.342, negative 0.940. Then we put that into our projection equation with g, and we get 0, that's g's x, u's x, which is, we just got 0.32. Then we have that side added to g's y, which is negative 12, times u's y, which is negative 0.940. We have the all over u's force, which is 1, so you don't even need to put that, because divided by 1 is the same thing. You do all of that multiplied by both sides of u. So you get this answer right here. You get that answer. And then you multiply it by you multiply it by u. So, your final answer for that will be 3.86 negative 10.6. That's equal to F2. Then we have to find the answer, put it into that equation, fx squared plus fy squared all under the square root. Putting that into the calculator with the values right above it, you get 11.3 is equal to F2. So there's our second answer for the force orthogonal. So we now have these two answers. And let's just erase all this. Alright. Now we have to find the second part of the problem. The second part, or the final part, the third basically. We have to find the resultant gravity when a second source is added, that source of gravity being at 10 degrees east of the original one, which is 270, so it's 280, and it has a force of 4 newtons. So I used, U, X, our original, we already had that in like the first step, right there, it's equal to 0. Then we'll do Uy is equal to sine 270. We also had that. We had it equaling negative 12. Then we're going to add V. V is our new one that we just got. So V of X, 4 newtons, and then since it's the X component, it's cosine. And then I explained why it's 280. And then a calculator is 0.695. Then we do Vy. Vy, 4 newtons again. Sine is Y. 280, because it's 10 east of the original 270. That is equal to negative 3.94. Now we're going to use the dot product. The dot product is Ux plus Vx, then Uy plus Vy, and that's going to equal Gx, Gy. We're going to do that, we're going to put all that in a calculator, and you get 0.0695, negative 15.9. So that's equal to Gx, Gy. Now we need to find, because the answer wants G in the resultant. This is the resultant in magnitude and direction. So magnitude, you would do square root of Gx squared plus Gy squared. Basically, when you put that on a calculator, you get magnitude of G is 15.9. It rounds to that. So there's another answer, and then for direction, theta, we're going to put it as, that's inverse tan then gy over gx. When that's put into a calculator, you get theta is equal to negative 87.5 degrees. Then you subtract that, though, and it rounds to 273. You subtract it from 360 is what I mean, because your direction can't be negative. So there is the final answer. And then I'm going to put those up here. There. So we have for our final answers, restated. F1 is the force of gravity in the direction of the incline, right there. F2 is our force orthogonal to that, right there. G, or the magnitude of G is our magnitude of the resultant vector in the second part when we add another force of gravity, 10 degrees east. And then theta is the direction of said resultant gravity. And that will be the end of our problem.